This is Algebra 1 lesson 9.1, solving quadratic equations by finding square roots. That's what we're doing. We're evaluating and approximating square roots, and then we're going to solve equations by finding square roots, beginning on page 503. Handful of definitions to start, or a few more than a handful. Positive square roots. What a square root means is when you see this symbol right here, this radical symbol, all it means as far as this class goes is what times itself. It's just like working backwards with using something squared, and we'll talk about that in just a few minutes as far as being how you undo it in our order of operations. But a positive square root, it's sometimes called a principal square root. This one here, a principal square root, is one of two square roots of a positive real number. If we were looking for the square root of 4, that's usually the simplest one for people to understand. We know that that's the number 2 times itself, so the positive square root would be 2. But, and we'll look at the next definition, it'll kind of clarify this in a second, there's another number that when you multiply it by itself gives you 4. The other number is negative 2. If I multiply negative 2 times negative 2, we know a negative times a negative gives you a positive. So it's both positive and negative. But most of the time when you're talking about square roots, you'll talk about the principal square root or the positive square root. But just know that there's also a negative square root. And just like I just showed you, all positive real numbers, when you take the square root of them, and it's easier to see on perfect squares, there's a negative value that when you multiply it by itself gives you the number as well. So positive and negative square roots, or principal and negative square roots. The radicand is the number or the expression that's under the radical. This is the radical. Whatever's underneath it, x plus 2, is the radicand. Perfect squares are numbers when you count, like 1, 2, 3, 4, 5, and it keeps going. 1 times 1 is 1. This is a perfect square. 2 times 2 is 4. That's a perfect square. 3 times 3 is 9. It will help you tremendously to learn these numbers. 16. 5 times 5, you're going to use them plenty in this class and plenty going forward in math classes. Learn your perfect squares. Perfect squares. An irrational number is a number that does not stop. The most common irrational number that you use or that you've used so far is the number pi. That number keeps going. You simplify that or you abbreviate that as 3.14 most of the time, or as 22 over 7. But both of those are approximations because that number keeps going. Any number that keeps going and doesn't repeat itself is an irrational number. 33.333, that's the one people think about. That number continues, but it's not considered irrational because it repeats. That's a rational number. This is not irrational. A number that doesn't stop and doesn't repeat is irrational. A radical expression has a radical in it. Easy. This is a radical. If it doesn't have this in it, it's not a radical expression. So the square root of 2 plus x is a radical expression. 2 plus x is not. Radical expression. A quadratic equation in standard form. Now, we've already been exposed to this since we did the chapters kind of in backwards order. Remember, ax squared plus bx plus c. We factored out x squared plus bx plus c. The only thing we didn't have on that was the a. Remember, we said we weren't going to fool with the a just yet. But you know it's in standard form. First off, you know it's quadratic. Quadratic is when it has x squared. You know that's going to give you a parabola shape, not a straight line when you graph it. But you know it's quadratic because of that. You know it's standard form because the biggest exponent, in this case 2, is first, followed by the next exponent 1 that's not shown, then followed by the one that doesn't have a variable at all. That's standard form. And the leading coefficient is when it's in standard form, it's the number that comes first. So standard form, again, ax squared plus bx plus c. A is the leading coefficient. So if that said 2x squared plus 3x plus 4, your leading coefficient would be 2. Here is example number 1, finding square roots of numbers. The first one says negative square root of 49. So it's saying negative, or in this case it'll act like negative 1 times the square root of 49. What is the square root of 49? What times itself is 49? We know the number 7 is. So 7 comes down, and then negative 1 multiplies by it. But it's also, so we'll leave it like that for right now. We'll talk about the other one in a second. But 7 comes down, negative 1 times 7 gives you negative 7. Here's an example of a negative square root. The square root of 49, notice there is no negative in front of b. So what times itself is 49? 7 is. That's a positive square root. Now this next one says the square root of negative 9. Notice how this one's different from A. The negative was outside of the radical for A. This time it's inside. What number times itself gives you negative 9? Think about that one for a minute. The number 3 should come to mind. That you're thinking on the right track if 3 comes to mind. Because 3 times itself, 3 times 3 does give you 9. But what number times itself gives you negative 9? When you multiply negative 3 times itself, like up here, negative 3 times negative 3, you know that's going to give you a positive 9. So you think to yourself, well, what about negative 3 times 3? That gives you negative 9. Sure does. But that's not a number times itself. Even though those numbers are similar, 3 and negative 3, one being positive and one being negative means they're very different numbers. So there is no number that when you multiply it by itself, that gives you the square root of negative 9. And notice this word right here, no real square roots. Some of y'all will go on to take Algebra 2. This won't come up till you take Algebra 2. There are a set of numbers called imaginary numbers. Everything you deal with in here are real numbers. But there are things called complex numbers, and the first version of that you'll deal with will be called imaginary numbers. And it just makes it to where you can work it mathematically, even though there's no real number that when you multiply it by itself gives you the number negative 9. So don't worry about imaginary numbers just yet. I'll tell you about it later. For right now, there is no number that when you multiply it by itself goes to negative 9. Okay? And then the square root of 0 is 0. Remember, it doesn't matter how many times you multiply 0 by itself, it's going to give you the number 0. Let's try some like this on the back. These are all really simple and really quick and really easy. What about the square root of 81? Just take about 10 seconds with it. Okay, we know what times itself. Remember, that's all this means. What times itself? The number 9. Know, though, that the number negative 9 times itself also gives it to you as well. We're only going to list the positive one right now, the principal one. What about negative square root of 81? Remember, this says negative 1 times the square root of 81. So again, the square root of 81 is 9. Then this comes down in front of it. So it's not like the one we looked at a second ago where the negative was under the radical. And then negative square root of 0. What times itself is 0. You know that 0 times itself is 0, and 0 is neither negative nor positive, so when that negative comes down, it doesn't even change what it is. For you to write it as positive or negative 0 is irrelevant. What about this one? When you see this symbol right here, this is a new symbol for a lot of y'all. It just means both positive and negative, so you don't have to write it twice. So what is the square root of 0.0016? When you look at this, the number 4 should come to mind because you see 16 in there. Everybody looks at 4, then you're like, oh, I don't know how many times. Point what? You know, like how do I move that decimal? Just count. I got to move the decimal from this point. 1, 2, 3. It moves 4 times. So you get the number 4. And then since it moves 4 times, you know it has to move twice for each one of these because you're dealing with multiplying something by itself. So it's positive and negative 0.04. And this is the twice I was talking about. Once, twice, right there. Because if you multiply that times itself, it'll wind up moving 4 times. So this is both positive and negative 0.04. This next one's a little bit easier. What about the square root of negative 9? And again, that's the same number that we dealt with in the example. It's not supposed to be. But the square root of negative 9, what number times itself is a negative value? There isn't one. So there's none for this one. Or no real number. Example number 2 is evaluating a radical expression, b squared. Or you read this as the square root of b squared minus 4ac, when a is negative 7, b is 8, and c is negative 1. This is called the discriminant. We talked only for 1 second before I cut it off at the last video about the discriminant. You'll get used to this over the next several years in math. You'll get used to this expression. But we're going to treat it just like anything else. We're just going to sub the numbers in, and we're going to work the order of operations. When you sub the numbers in, you get 8 in place of b, so 8 squared, minus 4 times in place of a, you have negative 7, and in place of c, negative 1. Then work your order of operations. Work everything under the radical first. So 8 squared is going to give you 64. Multiply everything else together. Negative 4 times negative 7. These two together give you a positive 28. But when you multiply them by the negative 1, it comes back to negative 28. So the square root of 64 minus 28. Simplify that by subtracting 64 minus 28. And we have something that says the square root of 36. What times itself is the number 36? We know it is 6. And remember, if you're talking about the principal and the negative square root, remember that could possibly be a negative 6 as well. We'll just talk about principles right now. Just want to remind you of that. Try this one. That's the same discriminant, the square root of b squared minus 4ac, to plug in with those values instead. 7, 8, and 1. Okay, let's take a look at this. Again, all of these numbers are the same. You just don't have any negatives creeping up right here. So talk about the square root of b squared. This is b, so 8 squared minus 4 times a. Here's a, 7 times c. Here's c, 1. So 8 squared is 64. Negative 4 times 7 is going to be negative 28. And negative 28 times a positive 1 is negative 28. You're still talking about the square root of all of that. So simplify that. 64 minus 28 is still 36 like it was earlier, and the square root of 36, or what times itself, is the number 6, and could be possibly a negative 6 as well. And we'll cover the rest of this tomorrow.